We're all familiar with the main asteroid belt out there.
Oh, absolutely. It's kind of hard to miss.
But have you ever stopped to think about just how many asteroids are actually out there?
Oh, it's mind-boggling, really.
And what those space rocks can tell us about the solar system?
It's like a window into the past, really.
That's exactly what today's deep dive is all about.
I'm excited for this.
We're looking at a recent discovery, all thanks to the James Webb Space Telescope. It's completely flipped our understanding of asteroid populations.
It really has. And there are some pretty interesting implications for planetary defense, too.
Oh, yeah. We'll definitely get into that a bit later.
Looking forward to it.
But first, let's set the stage a little bit,
Yeah, for sure.
When we think about asteroids, the first thing that usually comes to mind is the main asteroid belt.
Right, between Mars and Jupiter.
Exactly. And to date, we've cataloged something like almost 750,000 asteroids.
Most of them just in the last decade. It's amazing how much our knowledge has exploded recently.
It is, right. And most of these asteroids, as we said, are hanging out in that main belt. But then there are these other asteroids, the near-Earth ones.
Ah, yes, the ones that like to keep us on our toes.
Exactly. Those are the ones nudged a little closer to us thanks to some gravitational forces.
Right. And they're the ones we keep a very close eye on.
Understandably.
Yeah, potential threat and all. Gotta be prepared, right?
Absolutely. Now, the exciting part of this new research is that it's focused on the smaller asteroids.
Yeah, and this is where things get really interesting.
Because we tend to think about these big, dramatic objects in space. Planets, galaxies, black holes.
All right, all the flashy stuff. But sometimes the real treasures are in the details.
And that's what these smaller asteroids are. Little clues about the early solar system, even before planets formed.
Exactly. It's like looking back in time, we can actually see the building blocks of planets.
It gives us a glimpse into how Earth and all the other planets came to be.
Right, and it also helps us understand more about meteorites, the ones that hit Earth.
That's a whole other fascinating topic.
Yeah.
So we have this news article we're diving into today, and it focuses on this pretty surprising finding from the JWST. So what exactly did they find?
Well, the JWST detected 138 previously unknown asteroids, all in the main belt.
Yeah, 138. That's a lot of new asteroids.
Right. But here's the kicker. They're incredibly small. Only tens of meters in diameter.
Wow, that's tiny.
It is. And that makes them the smallest main belt asteroids that we've ever observed.
That's incredible. It makes you wonder just how many other discoveries are hiding in existing data, just waiting for the right tools and perspective.
You're absolutely right. It's all about having the right tools.
But hold on. How is finding these teeny tiny asteroids such a big deal? They're so small.
Well, because these little guys, they likely formed from collisions between larger asteroids.
Oh, I see. So they're kind of like leftovers from a cosmic fender bender.
Exactly. And by studying them, we can gain insights into the whole asteroid belt, like how it works, how it evolves.
So these small asteroids are like a key to understanding the bigger picture.
It's like piecing together a giant puzzle, one tiny asteroid at a time. And the more pieces we have, the clearer the picture becomes.
That makes a lot of sense. So these small asteroids can help us understand how the whole solar system formed and how it's changed over time.
Exactly. And the fact that we can now see things this small, thanks to the JWST, well, that opens up a whole world of possibilities for asteroid research. It's a game changer, really.
Now I'm really curious about how they even found these asteroids in the first place. I mean, space is huge, and we're talking about these tiny, tiny objects.
I know, right? It's like finding a needle in a haystack. But
Wow.
It's a great example of scientific serendipity.
What do you mean, like a happy accident?
Sort of. The researchers were actually analyzing data that was originally collected to study exoplanets.
Exoplanets, so planets orbiting other stars?
Yeah. They were looking at a star called TRAPPIST-1. They weren't even looking for asteroids in our solar system.
So they stumbled upon these tiny asteroids in our backyard while looking at another star system.
Isn't that wild? They were using this really neat technique called shift and stack to find them.
Shift and stack. That sounds intriguing. What is that?
Well, it involves shifting and combining multiple images.
Okay. And why would you want to do that?
Well, because it helps to reveal faint objects that are moving, things like asteroids.
Ah, I see. So these asteroids, they're not just sitting still in space, they're moving around. And by shifting the images, they could actually pick out anything that moved.
Exactly. It's kind of like how you can see a shooting star streak across the sky. It's easier to spot because it's moving, right?
Oh, that's a great way to put it. So they're using the movement to isolate these really faint objects.
It's a pretty computationally intensive process, but it's incredibly effective for finding things like these small, fast-moving
And
asteroids.
I'm guessing the JWST's sensitivity to infrared light played a big role here too, right?
You bet. That's one of the things that makes the JWST so powerful. It can see things in infrared that are invisible to our eyes.
Okay, so remind me, why is infrared light so important for seeing asteroids?
Well, asteroids are actually brighter in infrared than they are in visible light.
Really? I would have thought it would be the other way around.
It's kind of counterintuitive, but that's how it works. It's like having a special set of glasses that let you see things you couldn't see before, things that are hidden from plain sight.
And the JWST has those special glasses, so it can spot these asteroids much more easily.
Exactly. And that's why it's such a game changer. It's letting us see the universe in a whole new way.
So it's not just that the JWST is powerful, it's also that it's looking at space in a whole new light, so to speak.
I like that. A whole new light.
That's pretty cool. But let's get back to the discovery itself for a second. If these small asteroids are remnants of collisions, as we said, what does that actually tell us about the asteroid belt? Like how it's changing over time?
That's a great question. And it gets to the heart of what makes this discovery so exciting. It tells us that the asteroid belt isn't just a random collection of rocks floating around.
Yeah, I guess I always kind of pictured it that way, like a giant cosmic junkyard.
Well, it's more organized than that. It's more like, think of it as a family reunion.
Okay, a family reunion.
Yeah, but one that went very, very wrong.
I'm intrigued.
You've got these clusters of asteroids that are all related to each other.
Oh, I see. And how are they related?
Through collisions, of course.
Ah, right. The cosmic fender benders we were talking about.
Exactly. So imagine you have two large asteroids and they smash into each other.
Okay, I'm picturing it. A big, dramatic collision.
Lots of energy released and all this debris flying everywhere. And that debris, those are the smaller asteroids.
So they're like the offspring of the larger asteroids.
That's a great way to put it. And those offspring, they inherit similar orbits around the sun.
Oh, so they kind of stick together.
They do. And we call these groups asteroid families.
Asteroid families, that's a pretty cool concept.
It is. And these families give us a peek into the history of the asteroid belt.
So it's like we can look at these families and trace them back to the original impact.
Exactly, like a cosmic game of billiards.
Yeah.
You can see how the balls scattered after the break.
Oh, that's a great analogy. So by studying these asteroid families, we can kind of rewind the clock and figure out what happened in the past.
Precisely. And the more we know about these families, the more we understand about how the asteroid belt formed and how it's changed over time.
So these tiny asteroids detected by the JWST, they're probably part of these families, right?
Most likely, yes. And the more of these small asteroids we find and analyze, the better our understanding of the asteroid belt becomes. It's all about getting a more complete picture, filling in the gaps.
That makes sense. But how does all of this help us, I guess, in a practical sense?
Well, remember we were talking about planetary defense. Knowing how the asteroid belt evolves and changes over time is essential for that.
Oh, right. Because if we know how the asteroid belt is changing, we can maybe predict if any of those asteroids are going to come knocking on our door, so to speak.
Exactly. The more we understand about these asteroid families and their behavior, the better we can anticipate any potential threats.
So it's like having a better early warning system for incoming space rocks.
Exactly. We want to be as prepared as possible, right?
Absolutely. I mean, who doesn't love a good asteroid impact movie?
Oh, yeah, they're great for entertainment, but in reality, it's something we want to avoid at all costs.
For sure. So by studying these tiny asteroids, we're not just learning about the past, we're also helping to protect our future.
You got it. It's about connecting the dots between the past, present, and future.
It's pretty amazing to think that these tiny, seemingly insignificant objects can hold so much information.
I know, right? It's a reminder that sometimes the smallest things can have the biggest impact.
That's a great point. And I have to admit, this whole discovery has got me thinking, if we can find these tiny asteroids now, what else is out there? What other secrets of the solar system are we going to uncover with the JWST?
That's the beauty of science, isn't it? Every answer leads to more questions. And with the JWST, we have the tools to keep exploring and searching for those answers. Who knows what we'll find next? It's a very exciting time to be an astronomer.
I bet. So, what are you most eager to learn about next? What are some of the possibilities that this opens up for you and your research?
Well, one thing I'm really interested in is the composition of these smaller asteroids. What they're made of.
Ah, So we know where they came from, but what are they exactly?
Precisely. And some asteroids, they contain valuable resources.
Resources, like what kind of resources?
Well, some of them contain water ice, for example.
Water ice in space.
Yep. Sounds crazy, right? But it's out there. And that water ice could be crucial for future space exploration.
How so?
Well, think about it. If we want to send humans to Mars or beyond, we need fuel, right? And we need water.
Yeah, makes sense.
But launching all that stuff from Earth is incredibly expensive and difficult.
So you're saying we could use the water ice from asteroids?
Exactly. We could potentially mine those asteroids for resources. Imagine a future where we have fueling stations in space, all thanks to asteroids.
Wow, asteroid mining. That sounds like something straight out of science fiction.
I know, right? But with the JWST, science fiction is becoming science reality.
It's incredible. So this discovery, it's not just about understanding the asteroid belt. It's also about potentially using those asteroids for our own purposes.
You've got it. It's about pushing the boundaries of what's possible and finding new ways to explore and utilize the resources of space.
That's really exciting. But for now, let's bring it back down to Earth for a second, literally.
Okay, back to Earth.
This discovery has some pretty big implications for planetary defense, right?
Right.
I mean, we were talking about those near-Earth asteroids earlier.
Absolutely. Those are the ones that have the potential to get a little too close for comfort.
Right. Ones that keep planetary defense experts up at night.
Well, this discovery really underscores just how important early detection is.
Early detection. Why is that so crucial?
Because the sooner we spot a potentially hazardous asteroid, the more time we have to react.
Right. So we can come up with a plan to, nudge it out of the way or something.
Exactly. And the JWST, with its ability to see these smaller asteroids at greater distances, that gives us a huge advantage.
It's like having a better early warning system for incoming space rocks.
Exactly. And the more we know about the entire asteroid population, even the tiny ones, the better prepared we'll be for any surprises.
It's really incredible to think about. We're not just talking about adding a few more asteroids to a list. We're talking about a completely new understanding of the solar system and how it works, how it changes, and how we fit into all of it.
It really is a paradigm shift, and it's all thanks to these tiny asteroids and the amazing power of the JWST. Who knew that such small objects could reveal so much about the universe?
It's a great reminder that sometimes the biggest discoveries come from the smallest places.
I couldn't agree more. It's all about perspective, isn't it?
Absolutely. And with the JWST leading the way, I'm really excited to see what other secrets of the cosmos we're going to unlock in the years to come.
Me too. I have a feeling we're just getting started.
It's amazing, right? We've been talking about these tiny asteroids, and I keep thinking about how we couldn't even see them before.
It really is remarkable, isn't it?
Like, they were there all along, but our technology just couldn't pick them up.
Exactly. It highlights just how much we've advanced in our ability to observe the universe.
And it makes you wonder, right? What else are we missing?
Oh, I'm sure there are countless other discoveries out there waiting to be made.
I mean, if we can find these tiny asteroids now, who knows what else is hiding in the darkness of space?
That's the beauty of it all, isn't it? There's always something new to uncover.
And with the JWST, it feels like we've just scratched the surface.
Oh, absolutely. This is just the beginning. The JWST is going to revolutionize our understanding of the universe.
It's so exciting. It's like we've been given this incredible new tool, this new way of seeing the cosmos.
It really is. And it's not just about seeing things more clearly. It's about seeing things we never even knew existed.
And that leads to new questions, new possibilities, right?
Exactly. This discovery with the asteroids, it's challenged our assumptions about the asteroid belt and how it's changed over time.
So it's not just about adding a few more data points.
Mm.
It's about fundamentally changing how we view the solar system.
Right. It's about pushing the boundaries of our knowledge and being open to new ideas.
That's what science is all about, isn't it?
Absolutely. And it's what makes it so fascinating.
But it's also important to remember that these discoveries, they have practical implications too.
Oh, absolutely. We've been talking about planetary defense, and this is a perfect example of that.
Right. Knowing about these smaller asteroids, being able to see them, it helps us better protect our planet.
Exactly. The more we know about what's out there, the better prepared we are to deal with any potential threats.
So, in a way, this discovery is about safeguarding our future, not just understanding the past.
Well said. It's about connecting the dots between the past, present, and future.
And it also ties into that whole idea of space resource utilization, which we talked about earlier.
Oh, right, asteroid mining.
Yeah. Imagine if we could actually extract resources from asteroids. It would be a game changer for space exploration.
No doubt about it. It would open up so many possibilities. We could build and fuel spacecraft in space, maybe even establish permanent settlements on other planets.
It's mind-blowing to think about.
It really is, but it all starts with understanding what's out there, which is why this discovery is so significant.
It's a crucial step in our quest to explore and utilize the resources of space.
And it all goes back to the incredible capabilities of the JWST.
It's such a powerful tool. It's really revolutionizing the field of astronomy.
I couldn't agree more.
Well, I think that's a great place to wrap up our deep dive.
Yeah, I think so too.
We've covered a lot of ground today, haven't we? We talked about the science behind this incredible discovery, what it means for planetary defense, and even the future of space exploration.
It's been a fantastic discussion. I always enjoy our conversations.
Me too. And to all our listeners out there, thanks for joining us on this deep dive into the world of asteroid discoveries. We hope you learned something new and that you're as excited about the future of space exploration as we are. Keep looking up, stay curious, and who knows what incredible discoveries await us in the vastness of space. This is The Deep Dive, signing off.